Halo, saya Nanang Alisuttisna, staf pengajar di program studi teknik mesin Universitas Presiden. Saya mengampu beberapa mata kuliah dan salah satunya adalah Mechanical Engineering and CAD atau gambar mesin dan CAD. Pada kesempatan ini saya ingin menyampaikan apa yang dimaksud dengan gambar mesin dan CAD, materi apa yang diajarkan di dalam mata kuliah tersebut, serta sebuah cuplikan dari proses belajar mengajar pada salah satu topik yaitu toleransi dan suaian. Gambar teknik adalah media komunikasi di antara para praktisi bidang teknik dalam bentuk bahasa gambar. Gambar teknik bagi orang mesin sering disebut gambar mesin untuk membedakan tentang objek apa yang digambarnya. Dalam era digitalisasi, gambar mesin tidak terlepas dari sentuhan digital dengan digunakannya aplikasi atau software untuk menggambar yang disebut dengan Computer Aided Design, untuk selanjutnya disebut CAD. Program studi teknik mesin di Universitas Presiden mulai kurikulum 2020 telah mengaplikasikan CAD dalam mata kuliah gambar mesin dan diberi nama Mechanical Drawing and CAD atau gambar mesin dan CAD. Gambar mesin dan CAD diberikan kepada mahasiswa dengan tujuan agar mahasiswa setelah menempuh mata kuliah ini diharapkan dapat mengembangkan kemampuan mengungkapkan ide dan menggambarkan objek dengan cara menggambar, menginterpretasikan norma dan simbol yang digunakan dalam gambar teknik dan dalam kehidupan sehari-hari, mampu mengembangkan keterampilan dalam membuat gambar teknik dengan menggunakan bantuan aplikasi software CAD. Kemudian agar mampu membaca dan memahami gambar teknik. Pada mata kuliah ini, mahasiswa belajar tentang dasar-dasar gambar mesin menurut ISO dan praktek menggambar berbagai geometri dua dimensi menggunakan aplikasi atau software CAD. Topik-topik tersebut antara lain pengenalan gambar mesin, pengenalan CAD, standar gambar teknik berdasarkan ISO, gambar proyeksi, membuat dimensi pada gambar teknik, metode gambar potongan, toleransi dan suaian, metode menggambar ulir dan komponen berulir, serta gambar kerja yang terdiri dari gambar assembly dan gambar detail. Berikutnya mari kita lihat cuplikan proses belajar mengajar pada topik toleransi dan suaian.
I asked before whether you already know or you already learned about tolerance and fit. Have you learned about this?
Yes, sir. Before we have learned, but not many, sir.
I changed my question. Do you know what is tolerance and fit? Alvin, you know it?
I think just the basic, but not too detailed, sir. Like the type of the tolerance and how to measure the tolerance, type of fit. Just know the basic.
Okay. How about others? Teguh, do you know what is tolerance?
I do not yet. I do not know yet.
Okay. Dinda, how about you? Do you know what is tolerance?
Tolerance is setting of ruler regarding the measurement, sir.
Let me show you this. Do you see what is in my hand here? Anyone knows what this is?
I think that's something in motorcycle. I don't know what.
Yeah, this is part of the motorcycle. It's called CVT, continuously variable transmission. So your automatic motorcycle use this CVT to transfer the rotation from the engine to the wheel. When your part is damaged, can you replace it just buying this part from the shop or from the market and put it in your motorcycle, or do you need to change your motorcycle? Can you replace?
Yes, sir. Just replace it.
Will it be usable? Means that you can fit this into the original CVT. Even though you buy this from the market, you don't know from where this part is made, right? It can be in Japan, it can be in Taiwan, it can be in Thailand, or maybe it can be in Jakarta or Surabaya. Are you sure that you can use this part and put into your motorcycle? What do you think?
No, sir.
You cannot use this
We have to find the
when you buy
dimension
it from
of it.
as long as you know the part number, or you bring this part to the shop, to the market, then you just ask, I want to buy this one, and you can fix this together. Doesn't matter where it is made. The most essential question is why this part that you buy in the market that it was made somewhere can be fit into your motorcycle. Anyone can answer that?
I think maybe there are some standardization, sir, like ISO or
What if the size or the diameter of this hole is smaller? Because you see, when you make the part, it can be bigger or smaller from the nominal size that already given in the work order. Do you still remember that there may be some plus or minus allowance? It can be bigger, it can be smaller, but it can still fit in. So let's look at into this presentation. I'm going to share with you just a basic understanding what is tolerance and fit, because it's important for you as a mechanical engineer. So I will show you this. I will share the screen. Can you see it now on the screen?
Yes, sir.
Specifically for these tolerance and fit topics, you will be able to understand and the purpose of tolerance and fit used in engineering drawing, and you will correctly specify place and tolerance of drawing and identify the different types of fits and specify tolerance according to fits. Let's look at drawing that you may already seen before. In the previous exercise, there is an assembly consisting of pulley, number 1, shaft, number 2, nut, number 3, and washer, number 4. In shaft number 2, there is a dimension that has a suffix of G6. G6 is the tolerance for the shaft diameter. And there is also another symbol here, which is N8. That is referred to the IT grade of tolerance, and also the general tolerance of 0.1. Similarly, in the pulley, there is a tolerance. There is a hole with dimension of 36 H7. H7 is also the tolerance. And N8 is referred to the IT grade of the surface roughness. And the general tolerance is 0.1. But before going back, you need to understand that dimension is the most important aspect of the drawing. If you receive drawing without dimension, you cannot make the part out of that drawing. Deviation from the exact dimension are unavoidable. Why? Because the nature of manufacturing process is there, meaning that the person who make the part is different. The machine that was used to make the part is also different precision. Old machine and new machine and high precision machine and low precision machine will result or will produce the different quality, the different dimension, deviation. There must be a deviation. So as a designer, you have to define how big it can differ from the basic size. So you will need to define the upper limit and the lower limit. So your part will be useful. Otherwise, it will not function. Look at what is the tolerance. Tolerance is simply the difference between maximum and minimum size limits. So when you have this basic dimension, you may define diameter maximum and diameter minimum. So you can see here, the sub will always be made smaller than the basic size. The basic question, if you make the whole 10 millimeters and the sub is 10 millimeters, means 10.0 and 10.0, do you think it can fit?
Cannot fit, sir.
Cannot. Yeah, cannot. Yeah. The sub must be smaller than the hole. And how smaller? That's the question. So it's governed by the standard tolerance. Our concern is if you make the part with very high tolerance, a very tight tolerance, then it must be made by a very the high precision machine. So it will incur the higher cost. So if you want to make it very precise, high precision, then the part will be expensive. But if it is very low tolerance, then the part may not function. It's too loose, for example, because the difference or the tolerance is too big, so it might not be fit correctly. Let's say this example. If the dimension is 50 millimeters and plus minus 0.1, means that you can make the part between 50.1 and 49.9. So in between, you can make it between 50.1 and 49.9. It cannot go bigger than 50.1 or it cannot be smaller than 49.9. So your part will be in between. That's why you can make it anywhere. But as long as it is within the range of the limits, then the part will be function. Right? This is the illustration. So this is the hole with 50 plus minus 0.1. But the sub cannot be using 50 something. It must be 49.8 plus 0, meaning that it cannot be bigger than 49.8. And it can be smaller, minus 0.1. So the sub will always be smaller than the hole. Suppose that the hole is made with a lower limits, which is 49.9, and the sub is the maximum size, which is 49.8, but it still can be fit in because the sub is smaller, 49.8, and the hole is 49.9. How the tolerance is written? So this is important for you. If you look at this, it is the tolerance. The upper side, the upper dimension is the larger size, and the lower is the smaller size. Yeah. Or it can be like this in the hole, or it may be written in the single form. You put the upper limit, then put dash, then lower limit. So this is one of the way of writing the tolerance. The second way of writing tolerance is using plus or minus dimension. There are two types. The first is unilateral tolerance, where it's only go from 0 and bigger or from 0 and smaller, like this. Just one direction, either smaller or bigger. So in this case, it is 49.70, cannot be bigger than that, but it can be smaller than 49.70 with the tolerance of minus 0.05. Or it can use the bilateral tolerance. So you will have 49.65 plus minus 0.05, plus 0.05 and minus 0.03. As well as you use the same value for plus and minus. 57.20 plus minus 0.8. The cumulative tolerance 30.00 to 29.95. So the tolerance is only 0.05 here. But what happen with if all of this is given also tolerance 0.05? Let's say you make it 9.95, 9.95, 9.95. You are at the lower limit. What is the total dimension here? If you make it only at the lower limits, all of them, what is the total dimension here? Can you calculate this? 29.85. Is it within tolerance or out of tolerance? Out of tolerance. Your tolerance, your lower limit is 29.95. And in actual, you make it 29.85. So what's wrong with this dimension? It's supposed to be only two dimensions that is important, and you remove one dimension that is not important. If the total is not important, then you remove this when you make a drawing. If this part is not important, then you remove this. Or if this part is not important, then you remove this dimension. You cannot use this duplicate dimension. It will make it confused. The operator, they don't see this. They only make it 9.95, 9.95, 9.95. Then by the end of the day, the result will be 29.85, which is out of tolerance. So you need to remove one of the dimension that is not important. So you can look at to the right picture here. The dimension is not important. Okay, this is the basic understanding of the deviation. There is a so-called mental deviation here. This is a basic size. The basic size of the stuff is here, smaller size. But the basic size of, the basic size of hole is the smaller size of the hole. But the basic size of holes will be bigger than the basic size of sub. So if you look at this number, it means that if it is capital letter, means that is the tolerance of hole. If it is you see the lowercase, it will be for sub tolerance. So if you combine the fit, will be 50 H8 F7. The hole will have H8 for tolerance and F7 for sub tolerance. What is the value of H8 and F7? For diameter 50, I just would like to introduce you with the IT grade. When you look at this is and 7, it means that here, 8 and 7 here, if you make it as 8, then the process will be the center led, turning, boring, or reaming. Right? If you say this is 7, then it must be the high quality turning or broaching or reaming. So this is the quality of the surface. And it is related to the tolerance. If you choose the grade is 7, then the tolerance is between 12 micron to 35 micron. If you grade, the tolerance is between 14 micron to 50 micron. So this means that the ID grade 8, ID grade 7. And what means by H? This is the most important table as a designer or as a manufacturer. When you receive drawing, it said the hole is H7 and the sub is G6. What is the size? What is the tolerance? Now let's look at this table. I think I'll make it bigger. First of all is look at the, can you all see this number? The online students, can you see
Yes, sir.
this number here?
Yes, sir.
Okay, good. So our size is 50, right? Before it's 50, right? 50 millimeters here. So it can be here or it can be here. Or if in between, then you can use this as well. When the diameter size is 50 millimeters, then go to the H7 and G6 here. H7 for hole, use plus sign, and this 25 and 0 in micron. So your size is 50 plus the tolerance 0.025 and 0. So this is the value of the limits. And the sub is minus, G6 is minus. So 50 minus 0.009 and minus 0.025. So this is the tolerance. So there are two types of tolerance. What we have talked so far, the limit. And what is the geometric tolerance? Here, you have 20 millimeters, and you have the distance is 50 plus 0.05 and 0. And this size is 80.1 and 79.9 minimum. This is maximum. And this size is 100 plus minus 0.1. So it's called the limit tolerance, only for dimension. What if we want this side perpendicular to this side, or this side parallel to this side? Then you use geometric tolerance. So if you look at this symbol, it means that B is datum, B datum, C is this datum, but C must be perpendicular to B, perpendicular to B, and the tolerance is 0.05 degree. And this is the circularity or roundness. It cannot be oval. It must be round. And the tolerance is 0.001. So this is the so-called the geometric tolerance. Any question?
Sir.
Yes?
I saw the symbol through and M. Can you explain it again, sir? What does that mean?
Okay. M is a maximum material condition. Means that in case of shaft and hole, the maximum material condition is when the smallest shaft meet with the largest hole. So there will be a maximum clearance there. But the opposite of that is L. The symbol is L, least material condition. So when the shaft is the biggest and the hole is smallest. So the clearance is very small, the smallest clearance. So you can simplify this by saying that M is the maximum clearance between the two, and L is the minimum clearance. Does that answer your question?
Yes, sir. One more, sir.
Yes.
I saw there's a lot of datum in that part, and to determining the position of the datum, it depends on the engineer, or there are some standardization, or there are some.
No. You need to understand how this part is made. The first datum must be the one that is touch the table of the machine, because all other side will be based on that datum. For example, you make this part, then your first datum will be this, and the other here will refer to this datum. So let's say this is A, and this side is B. So A is here, and this is B. Yeah, or the whole. So the datum is the reference for others to refer to. For example, this B must be perpendicular to this. Okay. And this C must be perpendicular to B, for example. Okay.
Thank you, sir.
Right. Is there any question? Linda, no question? Then I will ask you a question. What is tolerance? Do you remember at the very beginning of this morning? Sorry? Okay. Abi, maybe you still remember? What is the tolerance? The deviation. Okay, Alvin? You said this morning you only knows a little about tolerance.
Yeah.
How about now? What is tolerance?
Itu tuh kayak apa ya, batas dimensi yang bisa digunakan ketika mau di ini nggak sih, sir? Ya, ketika mau di assembly atau apa gitu. Jadi batas dimensi untuk dimanufaktur. Batas atas dan batas bawah gitu.
Limits, upper limit and lower limit.
Yeah, lower and upper deviation.
And the definition of tolerance is the difference between the maximum and the minimum dimension for the tolerance. So remember, there are two types of tolerance. Anyone remember? What was that?
Geometric.
geometric tolerance, and another one is you can say dimensional tolerance or limit tolerance and geometric tolerance.